Today we will discuss some important questions related to electric potentials, children.
Point charge having a charge small q around a charge capital Q in a circle of radius smaller, the work done will be. That means, so here at the center, they are placing a charge Q, capital Q, and around this charge, small q charge will be revolving with a radius r. Now, work done will be. See, children, whenever you are going to calculate the potential at a different points around a charge at a distance, same distance r, at all these points, the potential will be same. That means if you consider this one as A and this point as B and this one as C and this one point as D, the potential at point A is VA and the potential at point B is VB and C. Like this, it will continues. But here, as the distances are same and the potential at these points are because of the charge capital Q. So the potentials VA, VB, and VC all are equal. So we can call this surface as equipotential surface. Okay, so according to the formula, work done W is equal to VQ. So that means here W is nothing but the amount of work done in moving a charge from one point to another point. So let us consider the 2 points VA and VB. In between those 2 points, the potential difference is given as VA minus VB. But as the potentials are same at all the points, so if you take the difference, you'll get 0. So the work done is 0. So option C. Now see the next question. Four equal charges Q are placed at the four corners of a square of each side A. Now work done in removing a charge minus Q from its center is. So now let us consider, okay, so let us consider a square like this and all the four charges are placed at the four corners of a square of side A. So they given that the side is A. So now at the center O, now they placed a charge that is minus Q, and now they want to take this charge to somewhere at infinity. Now they are asking us to calculate the work done in removing this negative charge from the center of the square to infinity. So now because of the four charges which are at the four corners, there will be some potential at the center of the square. So now let us try to find out that potential first. So to find out that potential here, there is no need to find out the potential at O because of all the four charges, children. Why means the charge is same and the distance is also same. So let us find out the potential at point O because of any one charge, and let us multiply that one with 4. We'll get the total potential. So now as the side is A and this distance from center to one of the corner of a square is given by A by root 2. So that means potential at O because of one charge, okay, that is at one corner, it is given by 1 by 4 pi epsilon naught Q by, in the place of R, we are going to write A by root 2. That is 1 by 4 pi epsilon naught root 2A, sorry, root 2Q by A. That is the potential. So now what is the total potential at O? Means it is 4 times that of the charge. That is 4 into 1 by 4 pi epsilon naught into root 2 q by a. Okay, so now here 4 will get cancelled. That is equal to root 2 into q divided by pi epsilon naught a. This is the potential at the center. Now they are asking us to find out work done. Okay, in moving the negative charge from center to infinity, that is work done is equal to negative charge, no, and what is the potential difference? V infinity minus V naught, V infinity minus V naught, that is equal to minus q into what is the potential at the center due to the four charges, root 2 q divided by pi epsilon naught a. So here minus into minus it is plus. So work done is given by root 2 into q square divided by pi epsilon naught a. So we can go with option 3. So let us move to the next question, children. See, as shown in the figure, charges plus q and minus q are placed at the vertices B and C of an isosceles triangle. The potential at the vertex A is given by. See, generally we know that because of a dipole, the electric potential at a point on the equatorial line is 0. So from the formula of the electric potential at a point due to a dipole is 1 by 4 pi epsilon naught p cos theta by r square. So here angle is 90 degree and cos 90 value is 0. So completely the potential at this particular point A, which is on the equatorial line of a dipole, will be 0. So now let us move to the next question. An electron having the charge E and a mass m is moving in a uniform electric field capital E. Its acceleration will be, so uniform electric field is like this. Okay, now a electron is there in that uniform electric field. So generally the electron will be accelerated. So whenever it is placed in a uniform electric field. So now it is going to experience some force also because of the electric field E, and that force is given by F is equal to EQ, and we can write this one as F is equal to E into E. As the charge they mentioned, it is a electron. Now according to Newton's second law, the acceleration produced in the charged particle because of the force which is having some mass m is given by F is equal to ma. So if you equate these two equations, E into E is equal to m into a. So acceleration is given by E into E divided by m. So we can go with option C. Okay, for this particular question. Let us move to the next question. Move to the next question. A proton is about 1840 times heavier than electron, which is when it is accelerated by a potential difference of 1 kilovolt, its kinetic energy will be. So kinetic energy, okay, we know the formula that it is q into v, and here they are talking about uh, a proton E. It is having a charge E, and the potential difference is given as 1 kilovolt. Kilo means we can write it as 10 cube volt. Okay, so directly we can write that one again as kilovolt. Why means here in the option they are asking in kilo electron volts. So 10 cube as it is, we can write it as kilo. So that is 1 kilo electron volt. Okay, so that is option C. Now see the next question. A thin spherical conducting shell of radius capital R has a charge q. So this is a thin spherical shell having a radius capital R and having the charge q. Another charge capital Q is placed at the center. So another charge is placed. Now the electrostatic potential at a point P at a distance r by 2. So let us consider this is the point which is at distance r by 2 from the center of the shell will be. Okay children, here 2 points. At this particular point P, okay, there will be a potential. So because of the charges that are accumulated on the surface of the shell, and second thing, because of the charge capital Q which is at the center, so one more potential will be there. Now let us try to find out the potential due to the small q charge. So even though that point is inside, as you already know that the potential will be constant inside the shell, even though the electric field is zero. Okay, potential will be there, but it is constant. So 1 by 4 pi epsilon naught q by r. Now, what is the potential because of the capital Q at a point P, which is at a distance r by 2 means 1 by 4 pi epsilon naught capital Q divided by, we can write the distance as r by 2. Okay, so now if you add these two things, then we will get the potential at that particular point. So that is small q divided by 4 pi epsilon naught r plus 2 capital Q divided by 4 pi epsilon naught r. Okay, so see the options. It is option D. Let us move to the next question. Electric potential of Earth is taken to be zero because Earth is a good conductor. It is a conceptual question, children. So next, an electric charge Q is placed at the center of a cube of side A. Hmm? Now, the electric flux on one of its face will be. So let us consider a cube like this, and now they are placing a charge small q at the center. Now they are asking the flux through the face. So now what is the total flux means according to Gauss law? It is q by epsilon naught. Now they are asking the electric flux on one of its face, children. So that means the flux through one of the face of the cube. How many faces are there, children? Totally for a cube, 6 faces. That means this total flux q by epsilon naught will be equally divided to each and every face of the cube. That is q by 6 epsilon naught. Okay. Next question. If the electric flux entering and leaving an enclosed surface respectively is phi 1 and phi 2, the electric charge inside the surface will be. What is the electric charge? So net flux, we know the formula according to Gauss law. It is the amount of charge which is enclosed inside divided by epsilon naught. But here they are asking the charge that is inside. So that is the charge enclosed inside will be is equal to the net flux into epsilon naught. So as you already know that the flux entering should be taken as negative, and the flux leaving the surface should be taken as positive. So here flux phi 1, this one, it is entering, and this flux phi 2, it is leaving. So if you take the difference, it will be phi 2 minus phi 1 into epsilon naught. So option B. Okay, let us move to the next question. Shown below is a distribution of charges. Now, the flux of electric field due to these charges through the surface S is. So, see the surface, children. How many charges are enclosed inside? So, actually, according to Gauss law, the master should consider the electric flux, and that electric flux is only because of the charges that are enclosed inside. It is nothing but q by epsilon naught. So how much charge is enclosed means 2q. It is enclosed by epsilon naught. Very simple conceptual question. See the next one. A hollow cylinder has a charge q coulomb within it. So it is having some charge q. If phi is the electric flux in units of voltmeter associated with the curved surface B. So this for this curved surface, okay, the flux associated is given as phi. Now the flux linked with the plane surface A in units of voltmeter will be. So now let us consider that this is a cylindrical portion. Okay, for this surface C, the flux is phi C, and for this surface B, so if you take it as phi B, but they given that one as phi in the question itself, and for the surface the flux is phi A. So now according to the Gauss theorem, the total flux phi A plus phi B plus phi C will be is equal to the amount of charge enclosed divided by epsilon naught. So but here if you observe the diagram according to the symmetry, we can say that phi A is equal to phi C. So now I will write this equation as 2 phi A, okay, plus phi B is equal to q by epsilon naught. Okay, but here in the question they given phi B value as phi. So now 2 phi A plus phi is equal to q by epsilon naught. So 2 phi A is equal to q by epsilon naught minus phi. Okay, so we want phi A. Even bring the 2 also this side. Q by epsilon naught minus phi. So option D it is. Okay, let's move to the next question. A mole of a substance has a permanent dipole moment P. A mole of this substance is polarized by applying a strong electrostatic field E. The direction of the field is suddenly changed by an angle of 60 degree. If n is the Avogadro number, the amount of work done by the field is, okay, work done. W is equal to PE cos theta 1 minus cos theta 2. Okay, now W is equal to, as they given uh, n as Avogadro number, so n PE, okay, into, so what is the angle, children? Cos 60, sorry, cos 0 minus cos 60. So the W is equal to NPE into cos 0 L is 1 and cos 60 is 1 by 2. So what will be the work done, children? 1 minus 1 by 2 is 1 by 2 only. So 1 by 2 NPE. So option 1. So let's move to the next question without wasting the time. The diagrams below show regions of equipotentials. A positive charge is moved from point A to B in each diagram. So once observe, children, all of you here. What is the potential difference? Point A 10 and at point B 40. And here also point A 10, point B 40. And here also at point A 10, point B 40. And here also at point A the potential is 10 and here it is 40. So now in all the diagrams, what is the potential difference between the 2 points A and B? Same, no? So in all the 4 cases, the work done is same. When the potential difference is same, then work done is also same. According to the formula, W is equal to VQ. Same charge we are moving. So now the work done depends on what? Only one thing, that is the potential difference between the 2 points. As in all the cases, the potential difference between the 2 points is same, even the work done is also same. Next question. An electric field of 1000 volt per meter is applied to an electric dipole at an angle of 45 degree. The value of electric dipole moment is 10 power minus 29 coulomb meter. Now, what is the potential energy of the electric dipole? Potential energy they are asking children minus P bar dot E bar. So, or simply we can write it as minus PE cos theta in magnitude form. So, minus P value 10 power minus 29 and E value they given it as 10 cube 1000 and theta value 45 degree. So that is minus 10 power minus 26 into 1 by root 2. So after simplifying, we'll be getting it as uh, minus 0.707 into 10 power minus 26. But in options, so they given that one. So adjust the decimal points. So 7.07 into 10 power minus 27 joules. Okay, that is option B. Now, let us move to the next question, children. See, 2 point dipoles of dipole moments P1 bar and P2 bar at a distance x. That means it is like two short dipoles, children. So this is of dipole moment P1 bar and this is one more short dipole of dipole moment P2 bar. Both are having some distance x. Now the force between them. So this is a parallel combination, no? As we already discussed in the class regarding this, uh, two short dipoles, force between two short dipoles when they are parallel to each other. That is 1 by 4 pi epsilon naught. It is 3 P1 P2 divided by R power 4. So here, if they are asking about the nature, as the force that we got it here, it is positive. So the nature of the force is repulsion between them. Okay. Now next question. A cone of base capital R. See, just imagine a cone like this. Okay, its base radius, this one, is capital R, and its height is given as h. Is located in a uniform electric field, and that too, it is parallel to the base. Now the electric flux they are asking. Electric flux formula EDS cos theta, no? Right? So now flux phi is equal to E into what is the area? Height into base radius. So into cos 0 degree. So cos flux phi is equal to E into H into R. Very simple question, children. So let us move to the next one. An electric field E bar they given 225I plus 30J exists in a region of space. If the potential at the origin is taken to be 0, then the potential at x is equal to 2 and y is equal to 2 volt. So we know that the relation between electric field and electric potential as E is equal to minus dV by dr. And now they are asking about potential V. It is nothing but integration of dV. So we can write it as minus E dot dr. So V is equal to minus integration of. So we are going to take the components of that. Okay, dr, that is 25 into dx plus 30 dy. So here at the point 2 comma 2 they asked. Y means in the question they given at x is equal to 2 and y equal to 2. That is minus integration of 25 dx plus integration of 30 dy. Okay, from 0 to 2 comma 2. Okay, so integration of dx is x, so we can write it as 25x plus 30y. As we all know the limits, x and y values are given, so minus of 25 into 2 plus 30 into 2, it will be minus 50 plus 60, that is equal to minus 110. Okay, here option. Next question, see. Assume that an electric field is given along x-axis, that is 30x square, exists in space. Then the potential difference Va minus V naught, where V naught is the potential at the origin and the Va is the potential at x is equal to 2. Okay, this is also similar type of question. We are supposed to calculate the potential, that is E bar dot dr bar minus, that is minus from 0 to 2, electric field is given as 30x square into dx, that is minus, so 30 into integration of x square dx from 0 to 2, that is minus 30 into x cube by 3 in between the limits 0 to 2, minus 30 into, if you substitute 2 in the place of that variable, 2 cube is 8 divided by 3, so it is minus 80 volt, or we can write it as joule per coulomb also. Okay, so this is the question. Next, charge capital Q is uniformly distributed over a long rod AB of length L as shown in the figure. Now the electric potential at a point O, in the diagram they given the point O lying at a distance L, okay, from the end A is, okay. Now the electric potential they are asking, again same thing, L2 to L 1 by 4 pi epsilon naught Q by R. Okay, let us take this one as X distance. Okay, Q by X. Okay, here let us consider a small element of dx. Okay, and the distance of this element from the point is X. So like that we can imagine. So into dx. Okay, but here, as the charges are not distributed on the surface, as the charges are distributed over the length, okay, here we are going to consider this one as integration. All of you observe, from L2 to L 1 by 4 pi epsilon naught Q by L, the amount of charge present per unit length, into dx divided by x. Okay, so now write down the variables inside and the constants out. So 1 by 4 pi epsilon naught Q by L, integration from L to L 1 by x dx, which is nothing but log x. So Q by 4 pi epsilon naught into L. So sorry. Okay. So now log 2 we can write ln 2. Okay. So that is option A. We can go with. Why means after that we will be getting 2, no? That is uh, after doing integration, 1 by x dx is nothing but log x. Nothing in the place of x, we are going to substitute upper and lower limits, so we will be remaining with that 2 value. Log 1 will become 0. That is the reason why. Next question. In a certain region of space with the volume they given children 0.2 meter cube, the electric potential is found to be 5 volt throughout the magnitude of the electric field in this region. So inside, okay, there will be potential, but electric field is zero, as we already discussed in the concept. Okay, next. A short electric dipole has a dipole moment 16 into 10 power minus 9 coulomb meter. The electric potential due to the dipole at a point at a distance of 0.6 meter from the center of the dipole situated on a line making an angle of 60 degree. So let us imagine a short dipole like this. Okay. Now this is the center of the dipole, a line that is making an angle of 60 degree, and the distance of this point is 0.6 meter from the center of the dipole to this particular point P, and they are asking us to find out the electric potential here, and dipole moment also given as 16 into 10 power minus 9. So here this is the question basing on the concept of electric potential due to a dipole at any point. What is the formula? V is equal to 1 by 4 pi epsilon naught P cos theta by R square. So V is equal to, we can write this one as 9 into 10 power 9 into P value 16 into 10 power minus 9 cos 60 degree divided by R square, that is 0.6 whole square. So V will be E is equal to, after simplification, we are going to get 200 volt. Next question. Two identical electric point dipoles having the dipole moments P1 and P2 given and are held on the x-axis at a distance of a from each other. When released, so they move along x with the directions of the dipole moments remains unchanged. If the mass of the dipole is m, so then their speeds when they are infinitely apart, far apart is. So let us imagine that these two dipoles, as they given in the question, they are along x-axis. Okay, they are along x-axis. Okay, one is P1 and they given it as Pi cap. That is, it is along positive x direction. And another one is P2. They given in the question as minus Pi cap. That means that is quite opposite to each other. And both are held at a distance of a. Both are held at a distance of a. Okay. Now they release it suddenly. So that means, children, here initially there will be potential energy between the two dipoles, but when they release it suddenly, so they will be moving towards each other. And that too, in the question they given that they are in the same direction. They will continue the same direction. So now here, according to conservation of energy, according to the conservation of energy concept, the total energy before leaving is equal to the total energy after releasing the two dipoles. So initial kinetic energy plus initial potential energy will be is equal to kinetic energy final plus potential energy final. So initial kinetic energy is zero because both are at rest, plus potential energy they are asking. That is, so two short dipoles. So if you use that formula, so we can be writing that one as uh, 1 by 4 pi epsilon naught 2 P1 P2 by R cube. Basing on that formula, 2 P1 P2, as both are same, P square we can write, and it is R cube means we can write it as A cube. Why the separation is given in the question as A. So that will be is equal to the kinetic energy of the two, half mv square into 2. Why I'm writing here 2 means both the particles will be having the kinetic energy. So we are going to add both. So that is here 2 will get cancelled. So now they are asking us to find out the velocity, no? So 2p square divided by 4 pi epsilon naught a cube is equal to mv square. Now v square is equal to 2p square divided by 4 pi epsilon naught m into a cube. Now if you bring that square this side and some of the terms out, so p square will come out, it will be p, and among this a cube we can bring a square out, it will be a, and one more a will be remaining inside the root, that is 2 divided by 4 pi epsilon naught m into a. So here 2 also will get cancelled, 2. So velocity finally it will be p by a into square root of 1 by 2 pi epsilon naught m into a. Okay, so now let us see the next question, children. Concentric metallic halo spheres of radii capital R and 4R holds charges q1 and q2 respectively. Given that surface charge densities of the concentric spheres are equal, now the potential difference. Surface charge densities are equal, and now the potentials they are asking. So is equal to from R to 4R E into dr we can write. Okay, so that is simplifying this, as we know that electric field E is equal to 1 by 4 pi epsilon naught, so q1 by r square. So if you substitute from r to 4r, 1 by 4 pi epsilon naught q1 by r square into dr. Okay, that is 1 by 4 pi epsilon naught into q1 integration from r to 4r 1 by r square dr. So we can write this one as integration of r power minus 2 dr, children, as you know that. So it is r power minus 2 plus 1 divided by minus 2 plus 1. It will be r power minus 1 by minus 1, that is minus 1 by r. So we can write this one as q divided by 4 pi epsilon naught into minus 1 by r in between the limits r to 4r, that is equal to q divided by 4 pi epsilon naught into minus 1 by 4r minus into minus plus 1 by r. So now if you further simplify this, q divided by 4 pi epsilon naught 4r LCM ತಗೊಂಡ್ರೆ, so it will be minus 1 plus 3, right? Minus 1 plus 4r square LCM ತಗೊಂಡ್ರೆ 4r ಅಂದರೆ minus r plus 3r ಆಗುತ್ತೆ. ಸಾರಿ 4 ಆಗುತ್ತೆ, it will be 4, right? So finally q by 4 pi epsilon naught into 3 capital R divided by 4 r square, 1 r will get cancelled, so that is 3 by 4r. So v is equal to 3 capital q1, 3 capital q1 divided by 4 into 4 16 pi epsilon naught r. So option A. So here two concentric spheres, children, of radii, capillary, and so here we can go with this diagram. So even if you want to know the diagram, it is like this. One is of capital R and another one is capital 4R. So now Q1 is the charge and the capital R is having a Q2. This is the diagram for that. Let's move to the next question. Consider two charged metallic spheres S1 and S2 of radii R1 and R2 respectively. The electric fields E1 on S1 and E2 on S2 on their surfaces are such that E1 by E2 is equal to R1 by R2. Now, the ratio V1 by V2 of the electrostatic potentials on each sphere they are asking. Okay, now what is the electric field, children? E1 first. We can write it as KQ1 by R1 square. Similarly, E2, KQ2 divided by R2 square. And now they are talking about E1 by E2, already given in the question as R1 by R2. Okay. Now E1 value, E2 value we know, no? KQ1 by R1 square divided by KQ2 divided by R2 square will be is equal to R1 by R2. So here K will get cancelled. We'll get Q1 by R1 square into R2 square divided by Q2 is equal to R1 by R2. Now Q1 divided by Q2 is equal to, if you take this R1 that side, it will be R1 cube and R2 cube. So we got Q1 and Q2 values like this. Now let us find out the potentials ratio. V1 by V2 is equal to formula KQ1 by R1, KQ2 by R2. Okay, K will get cancelled and Q1 by Q2 into R2 by R1. Again, we know that Q1 by Q2 values, no? So now V1 by V2 is equal to R1 cube divided by R2 cube into R2 by R1. So one R1 will get cancelled and square will be the remaining. So that is V1 by V2 will be is equal to R1 square divided by R2 square. Now let's see that last question. A sphere encloses an electric dipole with charge. Okay, 3 into 10 power minus 6 coulomb. What is the total electric flux across the sphere? Okay, a sphere encloses an electric dipole. What is the net charge of a dipole, children? Zero, no? So if the net charge is zero, then what about the flux? Zero. That is the thing. Thank you, all of you.